Hello guys, welcome to Random Shortcut. So today we're going to be doing structure analysis on a wing as well as CFD analysis. So let's get started. So the first thing you're going to need is the airfoil coordinates. We're going to download that from this airfoil tools website. So here I'll be choosing 440. Thickness will be 15 and the number of points will be 100. Let's make this a closed trailing edge and plot. So this will be the airfoil which we'll be using. Copy the coordinates from there. Copy. Okay, close it. Let's create a new Excel spreadsheet and paste the coordinates here. So we're gonna split this. First, for that, we're gonna go to data. Yes. Text to columns. Fixed width. Next. Yeah, next. And finished. So here, the first row will be of the group. So it's gonna be one for all. And the next will be the number of points. Let's start with 1, 2, and drag till the last. Make sure the last one is 0 so that it's a closed one. Alright, and the last will be the z coordinates. The c and d are x and y respectively. Drag and drop. Alright, and now I'll be saving this as a text document. Save as to desktop. Naka 4415. Search for not that. Text tab unlimited. Save. Okay, close this, and yeah, check for the coordinates here. Everything is fine. All right. Okay, we'll close this now. So now let's open Workbench. Let's just get rid of the Excel file. Okay. So now let's drag and drop static structural, and we'll also be doing Fluent. So let's drag and drop that too. So now let's open Design Modeler. Okay. Here. Now we're going to choose the XY plane, normal to. So we're going to click on concept 3D curve. So curve from the coordinate file system. Open the text document there and click on generate. And there you have your airfoil. So now you're going to create surfaces for that concept. Surface from edges. Click on the edge. Click on generate. Yeah, apply and generate. And there you have your surface. Now let's suppress the line. Alright. Okay, now you're gonna go ISO. You're gonna extrude that surface. So now click, alright, apply normal to the XY plane. First, let's choose the face geometry. Face, it's not selected. Okay, geometry, face, apply. Okay, so the direction will be from the XY plane. Okay, apply. And we're gonna give the thickness of 2 meter and generate. Okay, generate. So there you have your airfoil section. So that is that for here. So we'll just stop. Okay, we'll close it now. We'll open the model now. Okay, here's your model. Let's mesh it. All right, mesh. Where is it? Okay, first let's suppress the surface body. Right click and suppress body. Yeah, okay. Now let's create a mesh. Mesh. All right, let's give the size of 0.25. Update mesh. Okay, the size is a little big. Let's give a little small now. Let's go with 0.05. All right, update. Okay. Hmm. Even this is big. Let's go with still smaller mesh. Let's go with 0.01 and right click update. All right, so now we have our fine mesh here. Okay, now let's fix the support on one face. All right, right click, insert. Is it fix support? Yeah, no, that's fix rotation. Okay, there's it. Fix support. Let's fix that face. Apply. Okay, now let's put a pressure force. Okay, pressure there on the top face. Click on apply and let's give around 100 and no 100,000. Okay, no, that's 10,000. All right. Let's give the deformation. All right, total, and yeah, solve it. So it's solved now. So this is the deformation for 10,000 pascals of force pressure acting on the wing surface. So this is a contour. I'll just smoothen it. Yeah, so this is a contour, and I'll play the animation for it. So yeah, as you can see, this is the total deformation. Okay, so this concludes the structural analysis of the wing body. So this is just a basic, simple one. So I'll close this now and let's continue with the CFD analysis. Okay, now let me open design modeler here again. So in design modeler, same. Let's just import the airfoil. So 3D curve, coordinate system, Naka. All right, open, generate. Okay, so there it is. So now we're gonna generate a surface. Again, generate. All right, now we're gonna suppress the line body. All right, that's done. Now we are gonna extrude the surface. So in the XY plane, uh, where is it? Yeah, extrude. For that geometry, that face, we're gonna select the face, that face. Click on apply. The direction, it's normal to the XY plane. Click on apply, and the thickness will be of 2 meters again. Okay, and then generate. Okay, now that we are done with the wing, so now we're gonna create a box, which is the boundary layer for the wing. So now let's go to sketching, create a rectangle. Okay, that's okay. Okay, now let's dimension this rectangle. So the vertical height from there V1, that is V2, and the horizontal. So that's H3 and H4 here. So we'll give H4 as 8 meters and the rest will be 4, 4 and 4 and generate. Now let's extrude this. Okay, extrude, apply with respect to XY plane, add frozen. All right. So everything is done. Check for it and click on generate. And now we have a surrounding enclosure for the airfoil. Now let's perform a Boolean operation. Go to create Boolean. The operation will be subtraction. So subtract. Target body will be the rectangular body, and the tool body will be the wing. So click on that and apply. Okay, so as you can see now we that removed the wing section, and now we're gonna suppress that surface body, and now we are done with that. So as you can see, we are created a body with the wing opening outlet. Now, so again, we're gonna create a rectangular box now. So this will be used for what is it, refining the tail section mesh. Okay, so we're gonna create a box behind the tail section, and we're gonna dimension it so that V5 and V6. So both will be given of dimension 0.16 or 18. V5 and V6 will be 0.18 meters. And click on generate, and that's done. Click on ISO. So we have another body. So we'll close this for now. Okay. Okay. Now let's open up meshing. So here's a model. So first thing, you're gonna hide the second rectangle which we did there. So solid, right click, hide. So there's that. Now we'll generate a mesh, and so this will be a CFD Fluent linear, and the size will be of 0.15 meter, and the maximum size also will be 0.15. So update the mesh now. Okay, as you can see, we got um, somewhat not so good mesh. So we'll do some refining now. As you can see, it's not a good mesh. So we'll refine it. Go to mesh, right click, insert, sizing, and select the edge of the wing area there. And go to the type and choose number of divisions. And let's keep the, okay, wait, it's the edge. And okay, the type is sphere of influence. Let's change that to, what is the number of divisions? Okay, the number of divisions. The number of divisions, let it be 420. Behavior, hard. And let's generate the mesh. Right click, update. So here you can see somewhat fine mesh. We're gonna still refine it. So as you can see, now we're gonna choose the insert. We're gonna do an inflammation. So right click, inflation, and we're gonna choose the entire geometry, and the boundary will be of the airfoil. So click on face, yes. As you can see, you can select the complete face of the airfoil and click on apply. And now we're gonna give the inflation option to be total thickness, and the thickness will be 12, number of layers will be 12, and the maximum thickness will be 0.016, and we're gonna update it. So as you can see, the mesh has now become an unstructured one on the inside surface. Let me just change the angle. First, let me change the sizing of the internals. It will be 0.01, and update the mesh. All right. So now let me, not that. Okay, let me just zoom in. Uh, just a second. Let me rotate it. Isometric. Yeah, as you can see now, the mesh is an unstructured one, but it's a fine mesh to some extent. Not so good, not so bad. And now I'm gonna show the body, which we hid first, and now we're gonna do another meshing. So we're gonna select that body and use it as a reference for meshing. So yeah, let's go to right click, insert, sizing. So choose the entire body, click on apply, and the type you're gonna change it to body of influence, and the influential body will be the second rectangle. Click on that and click on apply, and the element size will be giving it as 0.042, and let's update the mesh. So now we have meshed the entire body, so the tail section has a fine mesh as well as around the layers airfoil. You have good fine mesh. So now we'll name the inlet, outlet, and the symmetries using named selection. So, not that. Okay. So the front face will be the inlet, and I'm gonna rotate it now. And this will be named as an outlet. Right click, named selection. All right, outlet. The top and the bottom would be symmetry 1. All right, SYM1. And the other two sides will be SYM2, symmetry 2. So now the meshing part and the namings are done. So, and yeah, forgot about the airfoil. So we're gonna do the internal airfoil section and name it as airfoil. Okay, so now that's done. We'll close this and now open the solver. First, update the project. Okay, now let me open the solver. So I'm gonna give parallel double precision, change the processor's count to 4. This depends on your configuration. So now the Fluent solver is open, and here's a model, meshed model. We're gonna convert this model to a polyhedra. So first, before that, just let me make it a make a change. Go to views, view option. I'll show the front view. Okay, so yeah, there's the front view. Okay, now I'll change the domain to polyhedra. Yes. This makes the solving a bit faster. And now I'll change the model to K omega and K omega model to be SSD and click on OK. And now let's make sure the material is, or the fluid material is air. So it's air and the solid is aluminum. OK. Now let's give the boundary conditions. Double click on that. So the inlet will be velocity inlet and we'll give the velocity to be 50 meter per second. And the outlet is a pressure outlet and symmetry 1, symmetry 2, and the airfoil is wall. Okay. So now we are going to go with the reference values. So compute from the inlet and the reference zone is a solid. Okay. Now we are going to go for the report files. Okay. Monitors, and here we're going to need the report file for the force report of drag. Choose the, this is for the drag coefficient. So I'll just rename to drag co F and select airfall and the report file, plot and print to console. Okay. And we're going to do the same thing for lift coefficient. Lift co F. Okay. So these are the files we'll be getting. So now let's go close this and do the initialization. So let's initialize this. We'll go with the hybrid initialization because it's faster for me. And now that's initialized. Let's run the calculation. Before that, I chose the methods to be second order equations, so I forgot to record that part. All right, and we'll give the iteration to be 1200. So let's wait now. So here's a residual graph, and the next one will be the drag coefficient plot, and the other will be the lift coefficient plot. Okay, so this is the plots which we are asked for. So now let's go for contours, not that, graphics, um, graphics, contours, and let's give a pressure contour. Okay, so here's the pressure contour for the airfoil NACA 4415. Okay, as you can see. And now let's do a velocity contour. So this is the velocity contour. So that concludes our video on structure analysis as well as CFD analysis on the wing. So thank you for watching. Give it a thumbs up. See you in the next video.